Okay, so number 27 in chapter 19. So we have a proton. Now this problem assumes that we know about protons. A proton has a charge of positive 1.6 times 10 to the negative 19 coulombs and a mass of 1.67 times 10 to the negative 27 kilograms. You don't have to have that memorized. It's on the AP2 equation sheet. So what happens here? So it's moving freely in a circular path perpendicular to a magnetic field. So here's the situation. We have a proton that comes in, right? Comes into this region where we have magnetic field going in. This right here represents a region of magnetic field going into the page. And when the proton comes in, you use right-hand rule number 1. And as we discussed, what happens is the velocity's to the right. And with right-hand rule number 1, we find out that the force is upward. Now, whenever an object has the force perpendicular to the velocity, the resulting path is a circular path. So it's going to follow a circular path. In fact, let me make this magnetic field region bigger. So the path is going to be perfectly circular. If you look at this anywhere, so like when the proton is right here, which way is the velocity? It's up. The velocity is that way. So using right-hand rule number 1, the force is going to be that way, right? Just use your right-hand rule number 1. So since the force is to the left, the proton curves to the left. Let's just look at the proton here. Now the velocity is this way, so the force is going to be that way. So the end result here is when we sum the forces, and I want to erase velocity so we don't confuse that with force. Velocity is not a force. So summing the forces on the proton, what's the only force acting on the proton? The force of the magnetic field, right? All of these are force magnetic, the force of the magnetic field. So the only force is the force of the magnetic field. What is the sum of the forces always equal? ma, but this is a centripetal, right? Whenever an object is in a circular path, it has a centripetal acceleration. And centripetal acceleration is v squared over r. So we take that, plug it in there. Now, what's the equation for force magnetic? Well, for a charge moving in a magnetic field, it's QVB sine theta, where theta is the angle between B and V. So what's the angle here between the magnetic field and the velocity of the particle? 90 degrees, right? V points this way. Magnetic field is into the page. So this is going to be sine of 90. And what is sine of 90? 1. So we're just going to take this away. So we got QVB, okay, equals m v squared over r. So one of the v's cancels. And we end up with, so they want us to solve for what? Determine the magnetic field. So we're looking for B. So B is going to be mv over qr. Now, do we have enough info? Oh, one thing I didn't mention yet. It takes 1 microsecond to complete 1 revolution. What are they talking about right here? It takes 1 microsecond to complete a circle. What do we call that? The time for one circle is called the what? The period. So 10 to the negative 6 seconds. Capital T is period. Now, and the period is time for one circle, or time for one anything. Period is the time for one. All right. We need one more equation. Because at this point, can we solve for magnetic field? We've kind of hit a point where we're stuck. Because how do we work period? How do we work this into it? Right? How do we do it? And what else are we missing? Do we have the radius? Nope. Look, for any time an object is in a circular path. So let me make some room. Any time that an object is in a circular path, its velocity, the velocity for an object in a circular path, what's the basic definition for velocity? It is basically distance, which I know I'm cheating here. It's technically displacement. Velocity is distance over time. What is the distance around one circle? 2 pi r. What is the time for one circle? The period. So take this, plug it in for velocity. So now we're going to have b equals m 2 pi r over period divided by qr. And then now what cancels? R cancels out. And then we can solve this. I'm going to come over here. So now we got b equals 2 pi m over period times charge. So you go 2 pi, mass of a proton is 1.67 times 10 to the negative 27 kilograms. Period is 10 to the negative 6 seconds. Charge of a proton is 1.6 times 10 to the negative 19 coulombs. You punch that into your calculator, and it comes out as 0.0656. So the answer is B is equal to 0.0656 Tesla.